So next up is NTT and Wenyu Shen from NTT. And very pleased to have Wenyu with us today. Wenyu is the Senior Manager and Principal Architect at NTT Communications, where he's responsible for driving NTT Communications' Edge strategy. He's currently leading a project to develop a commercial edge computing platform that I'm thinking we're going to hear about today. And Wenyu is also a member of the technology leadership team with the ONF. So Wenyu, welcome, and please take it away.
Thank you for the great introduction, Taimon. And today it's really my honor to give this presentation in such a great industry event. Actually, I've attended the previous two-day program, very impressive with the informative talks. So I will also try my best today to present our latest activity in the edge computing and local 5G domain, especially from the viewpoint of an operator. What is interesting is that people are using the name private 5G in this event, but actually in Japan, we have another name, we call it local 5G. So there's a different definition for the name of private 5G. But anyway, in today's presentation, I will use the terminology local 5G. To begin with, please let me give you some background and the motivation of our activity in this domain. So as shown in the left picture, single cloud with the single access network was the standard topology for the enterprise ICT system, while with the rapid evaluation of the clouds and WAN technologies, we have seen a dramatic paradigm shift towards hybrid ICT, in which hybrid cloud with hybrid access network have been penetrating into the enterprise ICT system. Moreover, location-free and device-free work style has become the mainstream in our enterprise users in this new normal era. As a result, a platform which enables the enterprise users to realize their secure and comfortable use of the multiple clouds from any location has been highly demanded. Let us change the view a little bit into the OT networks. Actually, layering one line for collecting operational facility data in the factory has been a challenge so far, while managing disparate legacy applications was also regarded as a tedious task. Moreover, the remote work wave has been accelerating even in the manufacturing industry in this with COVID era. To answer all these needs, we believe that introduction of wireless technologies such as local 5G will not only accelerate the unification of the network infrastructure within a factory, but also the adoption of the remote control of production machines and transportation devices such as AGVs. Another key approach should be the introduction of the on-premises edge for realizing the centralized application management. This also will facilitate the adoption of many AI solutions that can be loaded very close to the machines and vehicles. Last but not least, we believe that integration of OT and IT will finally accelerate the unmanned factory. I will cover this in detail later. The network design for the industrial Internet of Things was regarded as a two-tier model compressed by the things and cloud, in which data used to be sent to and processed on the cloud, such as analysis, compression, and visualization. Due to the rise of the concept of edge computing, a distributed edge tier has been added between the things and the cloud, so that the cloud intelligence can be distributed to the edge, so that the data can be processed at the edge before sent back to the cloud. I think the industry has already reached a consensus on the value here, which is regarded to be providing low latency, to reduce one cost, to guarantee privacy, and to provide autonomy. Let us summarize a little bit here from a broader view. On one hand, with the background of with COVID, the promotion of digital transformation, cost reduction, our enterprise customers are actually seeking for a more robust, flexible, and extensible unified platform as a basis of their IT and OT infrastructure. While on the other hand, the enabling technologies such as hybrid cloud, hybrid WAN, edge computing, and local 5G has become ready to lead our customer to start their journey in the Industry 4.0 era. So, what is NTT doing in this area? I will share with you the whole story one by one in the following presentation. First of all, we launched a new network service called Flexible Interconnect. We call it FIC 2 years ago in order to offer advanced cloud connectivity. By utilizing this service, easy and on-demand connection between branches and the public cloud service such as AWS, Azure, GCP, and data centers become possible. So what's more, we have started to provide an IaaS infrastructure, we call it VXF platform since last year, in order to offer value-added function at the network edge, including SD-WAN gateway, proxy, security function for this multiple cloud service, connection service. It is actually an open platform in which a customer can bring in his own functions, and the bringing functions can be further added into a running service chain. Our production, the SaaS Fabric offering is based on this, FIC and the VXF platform that I've described in the previous slide. And VNF starting from a variety of gateway, including those kind of security service that I've described so far. And also, to a huge set of, functions such as firewall as a service, CASB, packet inspection, malware detection can be deployed on the network edges as well. In addition, the network edge directly connects to our multiple cloud connection service so that on-demand connection to public clouds can be achieved in few clicks. So in addition, the zero trust and the SASE function required for this new normal era highly relies on the distributed infrastructure. It enables secure and comfortable use of cloud, SaaS, and in-house IT from any locations, including homes, hotels, or even on the move. Moreover, in addition to providing a complete internet-only zero trust access network, we're offering a very unique SaaS access model which leverages closed, mobile, and fixed access and centralized authentication, which means that the user can access the cloud without actually accessing the internet, even outside their office. Now let's move our focus from the network edge to the on-prem edge, more close to our customer on-premise. I'm glad to announce that we are going to launch a new service in the next month, which is about an on-prem edge for realizing smart X for our enterprise customers. So what actually is the platform? It is actually a integrated platform to be installed at the customer sites. It is for realizing the data collection, storage, analysis, and utilization for our enterprise customer. The on-prem edge itself can be set up with zero touch, after which an operator can manage the site for the customer via a centralized controller and distribute a variety of applications onto it remotely. You can see in this picture, there are AI, IoT, SD-WAN, private IoT, private LTE, local 5G as an example of the application that can be loaded on this edge. In addition, from the technical perspective, it supports both virtual machines and containers natively at the same time, which also enables easy onboarding of customers built or SIR built application as well. So let's look at the uplink. So currently, LTE, broadband internet, MPLS will be supported in the first release, after which the 5G access will come soon, when large capacity, low latency, and dedicated slices for individual applications are expected in the future. The on-prem edge will be working closely with our local 5G service, which I think we launched early this year in commercial. In fact, NTT I think launched the service in March this year, and the service is featured with its sub-6 gigahertz spectrum selection, the standalone approach in the beginning, and the cloud-based 5G core setup. At the same time, we're providing one-stop managed services, from building customer environment to the cloud environment, end-to-end, which include the tasks such as the application for a license, for using the spectrum, the construction of high quality wireless network on premises in the customer premise, lots of tuning tasks necessary to adapt to different complex situation, according to different customers environment. And the integration finally to our smart data platform in order to seamlessly provide more value-added data process services to our end customer. So the left picture clearly shows a comparison among 5G millimeter wave and sub-6 gigahertz for 5G regarding the frequencies that they are using. One of the reasons that we go with sub-6 gigahertz is because it's regarded to be easier to handle the millimeter waves from the perspective of signal reception and the area size that one Keynote B can reach. The right picture presents a comparison between the standalone and non-standalone approach. In production, for local 5G service, we go directly with standalone in the very beginning is because of the greenfield nature of most of our customer deployment, and also on the behalf of the cost reduction viewpoints as well. So now I would like to share with you several use cases about our on-prem edge and local 5G service. An interesting one is the use for controlling drones. We installed the on-prem edge on communication towers, buildings, besides a device, we called it a Doppler lidar, which is mainly used to measure wind condition around. We send the real-time wind condition data to the on-prem edge, and conduct analysis in it in order to, visualize the real-time and predicted wind condition data. Autonomous control of the drones is still under testing, based on the real-time and predicted measurement result. So far, we have set up 3 comprehensive bases for the drone control compressed of a Doppler lidar. As shown in this picture, you can see it, a drone port for charging and hunger, and the on-premise edge for data processing in the communication buildings. But we are expanding the deployment to more cities in Japan in the following months. Another use case is for the autonomic detection at the manufacturing site. It's an ongoing deployment with our customer. Data are collected by camera on a moving battery card and sent real-time to on-prem edge for analysis via local 5G network. The AI solution actually running on the on-prem edge will help detect suspicious workers' behavior, intrusion, and abnormality in order to enhance security safety activities inside the factory. As shown in the deployment configuration in the right picture, in addition to the AI solutions, network functions such as SD-WAN for WAN access and the 5G UPF are also deployed on the on-prem edge as well. So finally, I would like to share with you several technical efforts that we are committing these days in order to move all these forward. So first, we are migrating aggressively towards a cloud-native platform architecture. Step 1 shows an as-is design of our current setup in production. Basically, we're deploying Kubernetes cluster on the existing hypervisor environment. We have already have some, virtualized platform, which we call, over-the-top deployment. However, the next milestone will be the pure cloud-native architecture, in which we are aiming at deploying Kubernetes as the only platform to manage all the application workload. One thing we should never neglect is that although container-based workload will be more and more popular in the future, for sure, there are always VM-based workload that we need to take care about. Legacy applications, for example. Therefore, to realize an integrated infrastructure that supports both virtual machine and container are the key enabler during this migration. We also put lots of effort in improving the performance and efficiency of operation of this edge computing platform. In order to increase the throughput, we have already introduced traditional approach such as DPDK and SLIOV technology in the very beginning. Basically, we make the V switch run in the user space instead of kernel space and associate the data processing thread with the designated CPU cores in order to improve the throughput. And for some specific use cases, for example, UPF as an example, where Y speed is requested, we will further connect the workload directly, to the physical NIC, passing, through all of the overhead in the middleware. In order to improve the performance of computing processing, such as image processing and AI inference, for example, we also onboarded FPGA and GPU chips as well on the servers, so that these kind of workloads can be offloaded to the hardware chips as well in order to get better performance. On the other hand, to establish a centralized CI and CD workflow for easy operations is another aspect that we are now investing heavily these days. As shown in the picture, where when the flow is established, dev teams in the company, will first run the continuous integration flow to build and test the new feature of the application and commit them to the centralized edge controller, as shown in this picture. After which, the onboarded application will be triggered automatically to be distributed remotely to the specific object edge as necessary according to the manifest files that are configured separately by the dev teams in advance. So to summarize a little bit, this picture actually presents NTT edge blueprint. The edge that we are pursuing is not only to provide low latency service, as many people mentioned nowadays, but also actually to achieve a fixed mobile convergence as well. So on one hand, what I mean, the fixed mobile convergence. So we are aiming at providing a platform for both fixed and mobile service. As shown in the picture, the platform comprises, 3 tiers edge location, where centralized cloud, network edges, and on-premise edges. On either of the location, We can deploy wireline service such as SD-WAN, VPN, security together with the mobile service such as 5G, LTE, and etc. In addition, value-added service such as AI, IoT can be deployed together as well. On the other hand, the platform that we're offering is composed by multiple fixed and mobile access options as well, including the internet, MPLS, LTE, and 5G. Therefore, no matter what access network you currently have and where you are, you can easily enjoy the services that can be deployed on the platform. Last but not least, the edge strategy has not only accelerated the computing and network infrastructure integration inside NTT, but also enabled an end-to-end service delivery based on the distributed edge, various access technology, and the cross-domain end-to-end orchestration. So thank you for listening. In this presentation, I presented how we take Industry 4.0 to the edge. We have made several important milestones with our customer in the area, including SASE, edge computing, SmartX. We believe that this effort that I demonstrate today will greatly accelerate the progress of the OT and IT convergence, and finally realize the digital transformation for our enterprise customer. So hope I can share with you more successful story about this journey, other following event. Taimo, now I would like to give the mic back to you and we can continue with the QA. Thank you.
And you, thank you so much. And so, where I'd like to start is, I noticed in two spots when you were talking about a level of customization I don't associate with, telco offerings. I think in your VXF offering, you said something about customers bringing their own function.
Yeah.
And I think in your edge solution, you talked about sort of optionally using GPUs or FPGAs. So, both sounded to me like you're building custom solutions for customers. Do I understand that correctly? And if that's the case, how are those built and how are those supported and maintained?
Sure. Actually, to start with the service offering, so we have the standard menu, for our customer. For example, as shown in this presentation, on the network edge, we currently provide maybe the SASE service, for the enterprise customer, so that even they are working outside the office, they can secure and seamlessly connect to their cloud environment. So some service is the standard offering, but we also see lots of customization requirement from our enterprise customer. For example, they want a specific VNFs that they want to load besides our flexible interconnect service, for example. So at that time, so we need to onboard those VNFs for our customer. So a very important technology here is to provide the onboarding platform to our customer. So by using that onboarding platform, a customer or the SIer or the operator can help to customizing the individual requirement for the individual customer in a very easy way. I think that's the one very important point to provide those kind of service as a platform. Am I answer your question?
You are. Yeah, thank you for that. So another question. This event is largely about private 5G, or as you're calling it, local 5G in Japan. And I think I noticed on one of your slides, as part of your local 5G service, you have, I think you said, quote unquote, apply for a license. You help the customer with that. So I guess I'm curious about the licensing for Sub-6 in Japan, and also curious about NTT's role. I mean, is it NTT that actually provides the license, or is there some other entity that provides the license in Japan?
I think so. The license is managed by the government. So we need to apply it for the license for individual case. So usually anybody, as long as they have the space, for example, a factory, for example, or an office space, so they can apply for the license, to the government. But sometimes, the application process is very, very, complex and tedious. So as service, as one service that we launched early this year, so it's a one-stop, service, local 5G service for our customers, so which includes the application of the license for our customer. But it's not only the application, but after we get the license, the wireless network, very, very complex according to different, customer environment. So we also provide some tuning, task, to provide customized service for our customer according to their specific needs and their specific environment on premise.
Sure. Okay, good. Thanks. And then maybe, last question that just came in, but is, you didn't, well, I think you did mention maybe, but from your public 5G network, are you providing and selling slices to enterprises in that way? I mean, people will talk about that quite a lot as well.
So currently, to be frank, no, not yet, to provide the slicing service yet. But as I mentioned in this presentation, so slicing is a very, very, promising area that we invest a lot these days. Finally, as I showed, I think in the last slide in this presentation, so we are aiming at providing an end-to-end service to our customer, from the on-premise finally to the cloud. So actually we have already have the component, like I mentioned, edge platform, on-premise edge platform, the network edge, and also we are providing the WAN network, the cloud interconnection service. So I think the last parts that we should do in the following days is to create the slicing facility, the slicing mechanism inside the the infrastructure that we have already provided to our customer, so that to finally realize the end-to-end slicing from the on-premise to the cloud to our customer. So I think that will be the next milestone that we're going to achieve in the following days.
Good, very good. Well, Wenyu, thank you very much. I know it's late for you. I appreciate you joining us at this odd hour for you. Terrific, great to have you, and thanks for joining.
Yeah, thank you.